Okay, now we're on the last page. So I was getting a little bit ahead of myself and closing things out a little bit too early in the video here. We have number 10, the very last set of questions asks about pedigrees. You are going to have pedigrees on your final exam, so I'm glad I realized it, so that we're able to do this last question together here. All right, so let's look at this pedigree. So Chan's syndrome is an autosomal recessive condition characterized by very curly hair, underdeveloped nails, abnormally shaped eyelids. In the pedigree below, so you see a little simple pedigree, only 3 generations are depicted here, and then it asks us in questions A, B, that should be A, B, C, and D. Got another typo there. A, B, this should be C, and this should be D. Some questions about the pedigree. So let's work through these. First off, letter A says, label the generations using Roman numerals. This is what we do. This is how you signify generations in a pedigree, is by Roman numerals. This is very simple. There's 1 generation here on this first set, so Roman numeral number 1. This would be our parents. Okay. Next line represents the 2nd generation, so this is Roman numeral number 2. Okay. And then this would be the grandkids, which would be the 3rd generation, Roman numeral number 3. And if it was a bit more complex pedigree, we would have generation 4, 5, 6, 7, 8, 9, 10, ever how far you want to go. Pretty simple here for this class. So letter A, label the generations using Roman numerals. It's exactly what we did. 1, 2, and 3 using Roman numerals. Letter B, label the individuals with regular numbers. Regular numbers means Arabic numbers. This is what we use, 1, 2, 3, 4, 5, 6. So we're just going to label the individuals from left to right. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9. That's all you have to do in B. Okay, label them with regular numbers 1 through 9. There we are. 1, 2, 3, 4, 5, 6, 7, 8, 9. From left to right, generation 1 comes first, 2nd gen comes next, 3rd gen comes next. Basic numbering, left to right. Letter C, label the genotype of each individual in the pedigree. The genotypes. Okay, let's go back up to number 10 and let's look at these traits. Chan's is an autosomal recessive. All right, recessive. So let's use the letter C for Chan's. So we would have capital C equals normal, and lowercase c equals Chan's. Okay, so there's our little key. Now, letter C, back down here, asks us to label the genotype of each individual in the pedigree. All right, we don't know. Well, first off, let's talk about a pedigree. Squares are males, okay? Circles are females. So if you didn't catch that in your earlier notes and videos, I'm telling you now, squares are males, circles are females. If they're shaded in, that means they have the trait, they're expressing the trait. If they're not shaded in, that means they're not expressing the trait. Could they be carriers? Yes. If they're not shaded in, it just means they're not expressing it. Okay, and we've got a case of dominance and recessiveness here in this question. So immediately, the only genotypes that we can do right off the bat are the males and females that have Chan's. Those are the only ones that we can do right off the bat, the ones that are shaded in. We know number 4 has to be lowercase c, because it's colored in. It has Chan's. Number 5 has to be lowercase c. And number 8 has to be lowercase c. Okay? Now let's think about this. For number 4 to have Chan's, that means the parents had to be what? Carriers. Right? The parents had to be carriers. So number 1 has to carry the Chan's, and number 2 has to carry the Chan's. Now notice they're not shaded in though. So if they're not shaded in, they don't have Chan's. So if they don't have it, the other allele has to be capital C, capital C. So the parents in generation 1 are both heterozygous because they had 2 children with Chans. So they passed it down. Okay? Now, number 3 is a male. We know it has to have at least a capital C because it's not shaded in. We do not know what the other allele is. It could be a carrier or it could be homozygous, capital C. We don't know. We're going to leave it blank. Or if you wanted to put both, you could. You could put big C, little c, or big C, big C. Either one. We just don't know. We could look at their offspring when that male marries a female and they have children. But for now, it's not connected. It doesn't have children. We don't know what it is. It could be homozygous or heterozygous. We're not sure. All right, let's look at number 6. To figure out number 6, the female, circle, female, the daughter of the first gen, we know it has to have a capital C because it's not shaded in. All right? We can figure out what the other one is because look, number 6 married number 7, and they had a child, number 8, with Chans. So if they had a child with Chans, then that means number 6 has to be a what? Kind of like the parents, has to be a carrier. So number 6 has to be big C, little c. Same way with number 7. It has to be big C, little c. Because number 8 got the 2 little c's. Now number 9 is going to be kind of like number 3. We don't know. It has to have a capital C because it's not shaded in, so it doesn't have Chan, so it's got the normal trait, but we don't know if it's a carrier or not. We would have to wait a generation, look at the offspring, and then make a decision based on that. And even then, it's just a statistical assumption that we would make. Okay, so that's all we can do for letter C. For letter C on the question down here. That's all we can do. We could do number 9 like we did number 3 and do it could be a little c or capital C's. We don't know. Those are the possibilities for that one. All right, let's look at letter D down here on your question. Which individuals must be heterozygous? Which ones have to be heterozygous? Well, number 1 and 2 have to be heterozygous. The first gen of parents, because that's when the Chans was introduced in that second generation. They have to be heterozygous. We also know number 6 and 7 have to be heterozygous because they had a child with Chans. They have to be heterozygous. Number 3 could be, we don't know. Number 9 could be, we don't know. So we're going to leave those off because your question says which ones must be heterozygous. The only individuals in this question that we know must be heterozygous is number 1 and 2 because they had offspring with it, and 6 and 7 because they had offspring with it. They passed that trait down. Okay? All right, now this actually does complete the practice worksheet. So again, any questions, please let me know. I encourage you to work through these. I encourage you to work through the other practice pages that I have for you in Canvas. The more you work at them, the more familiar they'll become. You'll get better at it at interpreting, and then when you go take your test, you'll be like, oh yeah, I know what a test cross is. Oh yeah, I know what codominance means. I can do this dihybrid cross. I got this. So I encourage you to work through all of those. Reach out if you have any questions. Good luck.